Um, Super happy to be here, and thanks for the AI Accelerator Institute for inviting me. And I'm also excited to see people in person and being able to, do these events in person after, hiatus for last 2 years. Um, and today, uh, my focus is going to be on talking about AI at scale. Uh, it is, I come from the enterprise side, and there are many dimensions to adopting AI at scale, than technology. I know there are lots of sessions today that will be focusing on how to, deploy AI at scale, using various technologies. And we just heard about the complexity of the landscape. I'm going to be taking a little bit, of the enterprise perspective, in doing that. And to better understand, this, I think it's helpful to know a little bit of the context. So, where I am practicing this deployment of AI at scale. So, I am part of Schneider Electric, as you heard. This is We are a large multinational company, about 29 billion, 30 billion, depending upon the exchange rate that we have these days, between euros and dollars. Um, Been about 120,000 employees, and presence throughout the world, with the major hubs in North America, France, India, and China and Hong Kong. We have We focus on the energy and industrial automation and sustainability. Uh, it's all about I say energy in the form of electricity, so that makes it that much more infinitely bendable, and optimizable using AI. Which actually leads me to the next topic: is even though we are a traditional company, in heritage and manufacturing and large equipment, we have a strong conviction in adopting AI in every aspect of our business, both in our products and as well as how we do business. And we embarked on a journey to deploy, AI at scale in the company. And what you hear from me is, some of our experiences, and hopefully that apply to your context as well. So before I go on, the what AI at scale, of course, I think there are plenty of definitions of AI. It's kind of hard to, everyone knows intuitively what AI is, and we had to make our own definition. It may not be perfect, but this is how we view it. Most people today, if and most of the audience here is probably reading the press, looking at the latest development in AI. You look at something like GPT-3, that it can generate reviews just by keywords, beautifully written prose. I've taught my kids to use this, to write paragraphs, and see how sometimes so simple it is to write, nice diction. The other one is images. I mean, this is a beautifully generated image by just prompts, using the image gen. Now, most recently, Microsoft announced that they'll be embedding that inside Microsoft Designer, which makes it easy that sometimes you spend a lot of time creating beautiful graphics that can be generated using a few keywords. And lastly, this is not the latest one, but still my favorite. For those of you who know it, is from 2001: A Space Odyssey. Where you really start to think about AI approaching the general intelligence, and something that can help you. But this is the general perception of AI. Whenever we talk about it in popular press. Now, we take a much more grounded approach to what AI is, which is to say that it is a set of technologies that can help replicate human cognition, things that people can do today in business. If that can be replicated with sufficient accuracy, we consider that to be AI. And we also have a broader definition of the technologies. I mean, machine learning and various varieties of it are are all well understood. But we also bring in things such as simulation and optimization. There are lots of problems in the industrial context that can be solved using simulation and optimization. And it is not a static optimization. It is going to be based on predictions, model predictive control applications, etc. So we consider that to be under the umbrella of AI. Chatbots is another one. Again, there is a debate whether it is a true AI or not, because it's based on of course natural language understanding and generating responses. But it's a great application because it can augment humans, who are working in the industry, whether it is in call centers or customer support centers, etc., where we can augment the experience. And robotic process automation, this is again a bit of a controversial topic, whether it is true AI or not, because it's somewhat repetitive tasks. But we do put it under the umbrella of AI, because it is in a sense doing things that humans are required to do today for lack of several things. Maybe it's not possible to integrate systems as effectively as one would like, or it's too costly or too dynamic. So this is a branch of technology that we put under the umbrella of AI. So that kind of gives you a general, perimeter of what we consider to be AI. And here are, some of the applications, not, I would say that totally unexpected, but you can see, for example, energy optimization. This is a big area of opportunity, especially in another, company like ours. Okay. Um, we talk about distributed energy resources. So if company places where you have multiple energy sources, solar, wind, and you have storage capacity available, unplanned disruptions happen, so we have an optimization based on predictions. Electric vehicle charging, and you probably have seen the growth in the electric vehicles, and the load that electric vehicles are going to put on the grid is going to be enormous. But on the good news is that these loads are highly flexible. These are the ones that can really be managed through software. So we see an opportunity there. Um, Building automation and optimization. Buildings are one of the largest consumers of energy, and consequently contributing to CO2 emissions. And there is a tremendous opportunity to optimize them. Um, Data centers, they are kind of buildings and things that enable us to have the Zoom calls and FaceTime videos, etc. They are the next large plants in the world. So uh, again, energy optimization in that. The other side is the asset efficiency. In industries where you have long-lived assets, it's super critical to maintain them, efficiently through predictive maintenance, anomaly detections, visual inspections, and industrial safety. So, as you can see, the angle here is a lots of interesting applications of AI in the industrial context, both to improve efficiency and automation, safety, etc. So that's the context, from where I'm coming, so you can see. So the approach that I will be taking on talking about AI at scale is in large enterprises where I think, as James was mentioning, there is every company is going to embark on AI. It's not a question of if, it is when and at what pace. And we started this journey, and we see the all dimensions that are required to deploy AI at scale. And it is not shocking when you see the keys for successful AI adoption at scale, because this is something that people have done previously for many large technologies, and it is the same. But AI introduces a certain unique challenges that we can dive deeper into. So the four areas that we focus on are four dimensions that I will look at is the use cases, technology, process, and people. And I start with the use cases. This is probably the single most important thing in deploying AI at scale, and get out of what I call as pilot hell. In large companies, if you see AI deployment at scale, what you see is plenty of pilots, lots of things that demo well, that show well, nothing ever reaches production. And the reason is, we look at it, from what can, this technology do, and, happy to, work on it, and it's exciting, but there is no solid business case behind that. So the approach that, we have taken, and we, see, giving us benefit is to start focusing on what are the use cases that are going to drive. And it's not just, choosing the right use cases. And in order to choose right use cases, you need to focus on the business value, the end user, and how it is going to, reach the end user, whether it is, to market, or to internal users. And we have taken broadly two categories, like in the enterprise. The first one is direct to customer. So this is where, the products that you sell, how can you enhance value of those products with AI? There are plenty of opportunities, especially in an industrial context. Again, I'm no expert in talking about insurance or banking, but in the industrial context, there is a strong drive towards, IoT connected devices that emit a lot more data, which means that you have opportunity to, leverage that, to, generate better predictions and improve asset life, so on and so forth. So that's the, direct to customers. The second one is indirect to customer, and we call it indirect to customer because this is about the internal efficiency. The business is, trying to improve the processes, but with the ultimate objective of enhancing value to customers. You don't just improve internal efficiency for the sake of it, but it is to delight the customer. So we take a use case first approach to make sure that there is a right business value, and then there is, a stage gate approach for the use cases. This is another important thing that we have learned is, if one has to define and be really confident about the use cases, it's going to take forever. You have to have the experimentation mindset and have the confidence to stop things when they are not working, because it's always tempting to keep things going on. And in AI, with so much of that is not deterministic, it is always possible. If only I can have one more data set, if only we can try it for some more time, maybe we'll get, the right level of accuracy of the model, or right benefit from that. I think at some point you cut your losses and you say that this is not working, and you move on. And the, enterprise world is messy. It's not, you can have great ideas, but implementation is hard. The other, way to do is to have a consistent measurement of the value, having a framework in place that allows people to agree on what the value is, so that when, when the use case is in fact deployed, we are able to measure the impact. And also be comfortable with the fact that the expectations don't always match reality, and which is fine. You learn from that, but sticking to whatever assumptions that were made as the only truth, is not going to take, the deployment anywhere. So, right use cases, business value driven, and being able to, stop them using a kind of a stage gate approach. The second aspect, okay, I didn't know this animation behind. The second part about, AI deployment is to have a comprehensive technology platform that is, key to, deploy AI at scale. Now, there are lots of cloud platforms, lots of tools and technologies that are available. It's, easy enough to go find a place to do it. What we have learned and we believe is that to do this at scale, you need to have a comprehensive platform that, you build, that you own. And this is possible only at, companies of certain scale, so I don't, consider this to be a gospel for everyone. And the reason for this is as follows. You need to have a complete life cycle consideration. This is another lesson that we have learned is, people are always excited about building the new technologies, but then how is that going to sustain? And in the case of AI, where you have model drifts, predictions change, you have to keep up to date with that. You need to have a full life cycle approach and ownership to manage them. not everything needs to be built in house. Even though it is, you have to have some level of ownership on doing things. So use best of the breed technologies that are available there, where they add value to a specific domain. So first use commercial platforms that are there today, whether it is AWS or Google or Azure. But there may be really special purpose tools and technologies for domains or specific problems that we apply, whether it is in specific anomaly detection. There are lots of ways to detect anomalies using different input signals, sensors, etc. And we are constantly on the lookout for unique technologies. And lastly, partnerships. This is not a game where you just kind of do things on your own and expect everything to work. You do need partnerships with technology vendors, with people who specialize in certain domains, to make sure that you reach the goal. Probably a large number of companies today that are in the big chart that you saw, James, that you were showing, may not be there 5 to 10 years from now. Okay, we have seen the technologies come and go for a long time, and it may sound harsh, but that's the reality. You have to place the bets. You have to be sure that this is something that you can manage, because this is a critical technology for the enterprise. It's not something that will come and go. So that's the technology. Having a platform approach, looking at full life cycle consideration, and relying on partnerships where you need help. The third aspect of this is what we call as a hub and spoke model. And again, this is in the enterprise context, where there are lots of actors. This is not a single sport. Many companies have different approaches on how to scale AI. What we have found is the right blend of combining a strong hub, which contains people with who can define the AI strategy, and how to drive AI portfolio. So we have a consistent view of AI portfolio, so there is no missing mass. Right set of technologies and tools, so there is no technical debt that is created as we go on, because everyone likes their tools, and at the end somebody has to manage them. Having reusable components, so we can scale and accelerate. And more importantly, the approach that we have taken is to generally centralize the resources that can focus on AI. And this is based on the belief that the resources are scarce, and we'll talk about that in a minute. The skills are also highly specialized. Distributing them, two data scientists, on one project somewhere is good, but after a while they are going to get bored. You need a way to cross train them, have a growth path, career paths for these teams. So we have a hub that is really focused on the strategy, technology, and the delivery and the resources. And then on the spoke, in our world, spoke could be a business function, or a line of business that is actually delivering the value to end customers. And this is where people are really owning the problem, owning the offer, and how to take it to market, and then integrate it as part of the larger offers that we make. Because AI is not a product by itself, at least in our world. We consider it to be an enabling technology into the larger product. And then having the the necessary resources to really scope the problem, provide access to data, because this is all the domain knowledge, and this is spread across different business functions and lines of businesses. But to combine these two, the common thread that we have is a use case. So everything really collapses onto having this single thread that allows people to come together to work on it, and either you take it to fruition or you stop it. And you hear me saying this, you stop it, because to me that is one of the big bold things that we do, is to say no. And in many cases it's very hard to say that, and it's tempting to keep on going. The next topic, our next dimension to that is people. In order to do AI at scale, because ultimately you need people to do this, and talent acquisition at scale is a full-time job. It's not easy. You have to go through. You have to have established processes to bring in people, onboard them. I mean, first of all, scouting for them, hiring them, onboarding them is not an easy job. So if you want to do AI at scale, you really need to think about what is the acquisition strategy. And second is to be a bit bold, on making bets on people. It's I think when you do things at scale, you will make mistakes. People may not exactly fit the culture and the environment, but it should not stop people from being a bit risk taking in bringing in new ideas and people. Um, on the other hand, we also need to think about the adoption by people, because ultimately this is whether you are selling products to market that are enabled by AI, which is non-trivial. People who are used to selling stuff, whatever they have been doing, and now you suddenly inject AI into that, need to train and make people ready. And internally, communication and community building to get the buy-in. There is always apprehension, especially in large scale enterprises. When you talk about AI, people think of jobs. Is AI going to take away the jobs? I mean, there are plenty of cartoons around that show that. And it is looking at AI as something that what we call as augmented intelligence. It's like augmenting humans, in things that they do. Um, and it is a way for people to bring people in together, communicate, share, and be transparent. I mean, there are some cases, where it is going to change. It's you know it's it's pretty obvious. I mean, people don't have these people taking phone calls and voicemails anymore. Technologists have always taken out adjusted jobs. I think really thinking carefully about people, both on people who build AI and people who are going to use AI, is crucial. If you want to do AI at scale. I'll spend a couple of more minutes and then leave some time for any questions. So I wanted to share few key lessons that we have learned. It's by no means an exhaustive one. It is things that we found very valuable as we went through this. So the first one is on the value generation. This is the true north. AI is to generate value. It is a tool. It is a very important technology, but ultimately it's about value. Having the right level of commitment to to deploy AI is key, and it is critical to not spend time in the pilot hell. Uh, Again, in my experience, I have seen plenty of exciting things, nothing that reaches production, and our goal is how to get things into production. Execution focus. Again, AI is like any other technology. You need to have the execution focus. You need to have the right people who are there to drive it. Even if it means we have to adopt the approaches, agile methodologies. We've got lots of approaches available. Hub and spoke to have the right level of interactions between businesses, functions, and the core AI technology. Um, I haven't talked a lot about data so far, which is one of the key barriers to AI adoption. So it would be nice if all data is available in a data lake that we can all go and work on it. And the reality is it's just a myth. And we can take the approach that, okay, let's try to solve our data problems, and then we will go and address AI. I think it will take forever, and it's never going to be successful. So the approach that is very pragmatic. Take use cases, high value use cases, try to address the data problems associated with them. If it means that you take some tactical approaches to bring in AI, bring in data that is necessary for the problem, so be it. Not everything has to be in a really clean data lake that is formatted, ready to be used, and or put it on Kaggle. So be very pragmatic about that. Planning for go-to-market, always envision where is this going to go? How is this going to be adopted? From the get-go, looking at this as a business problem and not as a technical problem. Building internal capabilities. If this is a technology that is as transformative as all of us believe, we strongly believe in that, it means we need to have internal capabilities to adopt that. And lastly, this is really a talent game. Doing AI at scale means you need to have the talent and be bold on talent. So I stop here to leave a few minutes for any questions. And by the way, any would be happy to connect with any of you to continue the discussion.
Early information science. I really like your emphasis on use cases. And I always say, there are fixed data problems, go through the use case where you need that data.
Yeah.
Are you building live, and I think those are assets that you build over time. So are you building libraries of use cases that you can apply to many different applications, or is it really more project specific?
So we are doing both, okay? And the approach that we are taking is we thought about, hey, you know what? There might be a classes of problems that we can solve, and let's try to build them. We use that as a framework to guide the discussion, but really build things once we see multiple use cases that have the general pattern. Again, this is being pragmatic, not to build things because we kind of like them. Yeah. They are measurable, there is value, and if I see 3 use cases that follow the same pattern, okay, let's build a component that we can reuse. Yeah.
Hey, I'm Matt. Sorry, Matt from LabelVox. Enjoy the presentation. I'm curious, of the models that get to production and solve business problems, what percentage are those? And then to follow up on that question, what are the barriers that are preventing those models that are in R&D or in some sort of project phase from getting to production?
Okay. So the first question is about what percentage. I would be a bit hard pressed to give the exact numbers, but it is smaller than I would like it to be. There are lots of things get dropped here, smaller than I would like it to be. But the ones that reach production are the ones that generate value, that are clearly being used, that have measurable outcomes on them. And what was your second question?
Second question was, the ones that are in that project phase or R&D phase, what's preventing them from getting to production and solving the business problem? Is it the value piece, or is it the fact that there's not enough data? What is that?
Yeah. So, 2 major barriers. The first barrier is the data, to really get the right level of data, right quality of data to solve the problem. Okay. The second one is the integration challenges. You might have a model, you might have something that generates the value, but it has to be integrated into an application or a business process to be really useful. And the integrations are complex because they have their own life cycle, their own timelines, etc. So those are the 2 main barriers for us. Yeah. There was a question here. Yeah. Yeah.
Internally some kind of mechanism on how to rank them. For example, you look at different attributes of a use case and say that these are scored, and I'm going to pick use cases that I can execute based on this type of quantification.
Yeah. So to answer the first question, I think it's business value is complex because this is kind of future projections and everybody has assumptions. What we try to do is to have a really simple framework of estimating it. Number 1. Number 2, allow it to evolve over time. I think the biggest challenge is if you have to commit to something right at the beginning as set in stone, people are afraid either you tend to be conservative or you tend to be over optimistic. Hey, I'm going to change job next year, so I can give you whatever you want, right? In big corporations. So it's important to be able to have a framework that is flexible and that can evolve. That's number 1. And in terms of rank ordering them, of course, you have to think about what is in future. I mean, there is sometimes you cannot put a number on a strategic advantage that you might get certain things. But typically, it is really focused on the business value framework that also includes the strategic benefit that we have. We've got a simple framework that we use.
Yeah, question. So for the internal capabilities that we're building, how do you address the need for the coding professors that want from silicon all the way out to the cellular stack? Is that something you can find partnerships with, or are you building all of that internally?
So we are not doing as much today on when you say from the silicon, we are not building hardware accelerators for AI, etc. It is primarily a software stack. We do have a device side AI that we are embarking on, where we have to have partnerships, and we don't build silicon. We use the ones that are available. Like for example, STM ST Microelectronics has a new kind of chip, that microcontroller, that we can use in many applications that has sufficient capabilities. We also, in terms of the stack, what we see is we are adopting the commercial tools, but we build the layer of the MLOps that is required on that, which is the tooling that we have of our own, that takes into account whether someone is working on AWS. I mean, to be very clear, using Terraform scripts, right? Everything that allows us to work on both platforms. So we are not trying to build everything ground up on our own, but the integration layer is completely owned by us. Yeah. Okay. Thank you all. Thank you.